Hello everyone. So in this video I'm going to be explaining the conversions between mole and number of particles. So previously we looked at the mole concept, just a little introduction. We started looking at what the mole is, and we said that the mole is defined as the amount of substance that has as many particles as there are in 12 grams of carbon 12. We also looked at the definition for molar mass, and we say that molar mass is the mass in grams of a substance, right? And the unit that we use for molar mass is G. I'm going to use my common letter G slash mole, and the unit that we use for mole is MOL. Right, we also looked at some let me fix my little, yes, we also looked at some conversions in the mole concept, and one of the first ones we looked at was mole, and we say that the mole is equal to the given mass divided by the molar mass. And once again, the unit for mole is MOL, right? And we also looked at the conversion for mass, where mass is equal to mole multiplied by molar mass, right? These were the ones that we looked at before. Now what we're going to look at today is, as I said, the conversion between the mole and the number of particles. But before we do that, we have to understand what the word particles mean, right? And I use this abbreviation AIM to remember what the particles are. So A represents atoms, I represents ions or ionic compounds, and M represents molecules. For A, atoms, right? Atoms are the elements that we find on the periodic table. So all the metals, the non-metals, the semi-metals, those are our atoms, right? And here are some examples: iron, helium, lead, hydrogen. All of those are examples of atoms. Once you see the word atoms, it's referring to particles. The next one is ions, right? And your ions would have, for example, a positive charge, so Na plus and Cl minus, or Mg2 plus. Those are ions. Ionic compounds are formed from the combination of a metal and a non-metal. An example of an ionic compound would be NaCl. So that's an ionic compound. Another example that we have here is KCl, right? It's formed from the bond between a metal and a non-metal. All right, that's your ionic compound. Ionic compounds are also referred to as formula units. Just remember this, because sometimes you might see the word ions, you might see the word ionic compounds, and you might see the word formula units. You need to remember these terms. These are particles. The last one is molecules, and molecules are really made from the bond between non-metals, only non-metals, right? And this is a covalent bond. So for example, the bond between a nitrogen and nitrogen atom, this gives us a covalent bond. Two non-metals coming together to give us a covalent bond, right? That gives us a molecule. And another example of a molecule is also carbon dioxide. Carbon is a non-metal, oxygen is a non-metal, so it's also a molecule. Right, just remember that the types of particles that we have our atoms that we see on the periodic table, we have our ions, ionic compounds, and formula units, and we have our molecules, which are our covalent compounds. Now let's look at our conversion, right? Now for the conversion, just remember first up what Avogadro's number is. Avogadro's number is 6.02 times 10 to the 23rd power. This is Avogadro's number. Avogadro. Yes, that's Avogadro's number. Right? And just a small recap as well. 1 mole of any substance is equal to Avogadro's number. Right? Alright, and that's why we can use it in this type of conversion between moles and number of particles. So here's our formula. The formula that we're going to be using is the number of moles is equal to the number of particles divided by Avogadro's number, right? And remember that your number of particles is AIM, atoms, ions, and molecules, right? Let us go ahead and get into one of these questions. I'm going to only be working 2 questions. I'm running out of time. I'm going to only be working 2 questions, and you're going to try the rest on your own. So I'm going to be working number 1, and I'm going to be working number 5, right? So let's do this. Key thing I might have forgotten. Yes, so we can also convert between number of particles and number of moles, like almost like you're swapping or you're making one of the things in your equation the main subject. All right, so number of particles is equal to number of moles times Avogadro's number. Let us put all of these into some little perspective. Right. So it says how many moles are in 3.0 times 10 to the 23rd molecules of oxygen gas. Now we cannot use a formula that says, I know probably the first formula that came to your mind was mole equal mass over molar mass. We cannot use this formula because in this question, as you can see, we were not given any mass. There was no mass given. Yes, we could solve for the molar mass using O2, but there was no mass given. So we cannot use this mole equation. Instead, the mole equation that we are going to be using is mole is equal to number of particles divided by Avogadro's number. Right, the Avo is my shorthand version of Avogadro. If you see me using Avo, it's Avogadro. Right. So let us put this into perspective. Remember, the molecules are a type of particles. So that's why we can even use this formula down at the bottom. Let us work. The number of particles that we got was 3.0 times 10 to the 23rd power. Right, that's our molecules. And Avogadro's number is 6.02 times 10 to the 23rd power. Right, and this is very easy to work because our powers will cancel out each other. This will be 10 to the 23rd power. Both will cancel out each other, and so we're left with 3 divided by 6, which is equal to 2. Right, the unit that you're going to be using, since we're solving for mole, the unit will be MOL. Always check to see what you are solving for. It gives you an idea as to what formula to use and also the unit that you must use at the end. You may ask questions in the comment section of the video. I will be looking out for my questions. Yes. Now, what if we're asked how many moles? Oh, I repeated my question. Let me just change this for a bit. Alright. Yes, I'm working out this one right here. Right, so this question says, calculate the number of sodium chloride formula units in 0.5 mole of sodium chloride. right? So what we're solving for, it says we're solving for formula units, right? And remember that formula units is a type of particle, so therefore we're solving for number of particles. So let us work. The formula that we got earlier, it says number of particles is equal to number of moles times Avogadro's number, right? So number of mole times Avogadro's number. Right, and the mole that we got was 0.5 mole, and Avogadro's number, you can see it, 6.0 times 10 to the 23rd power. And when we solve this, let me grab my calculator. When we solve this, it's gonna be 0.5 times 6.0 times 10 to the 23rd times 10 to the 23rd times 0.5. And my suggestion is that when you're working these in your calculator, please know how to use your powers and apply them in the calculator. Oftentimes in our scientific calculator, you might see an X with a box. That's how you insert the power. You might see, I think there's a one that has X with Y, right? This is how you insert the power up top on your calculator. I hope this gave a little bit of understanding to the topic. What I want you to do is that you're going to be solving these. You're going to be solving number 2, number 3, 4, 5, 4, 6, 7, 8, and 9. Right? And there's a final boss question. You can take a screenshot of this. It's posted in the classroom. There's a final boss question. How many hydrogen atoms are present in 3.02 times 10 to the 23rd molecules? Thank you for watching, guys. Bye.